Okay, here I have a video on conditional statements. The conditional statements used a lot of times in logic. It's used a lot in geometry and in proofs and things like that. So first let's start with what is a conditional statement. And a conditional statement is a statement that takes the form of if, then. It's made up of two parts. And this if part is called the hypothesis, and the then part is called the conclusion. And so if I have a statement that goes here, that's if blank, whatever comes after the if is my hypothesis, and the then part, the conclusion, can be Q. And this is the note. P and Q are letters that we use a lot of time to represent the hypothesis and conclusion. So this is a normal conditional statement. An example of a conditional statement I have down here at the bottom that we're going to look at a little more in a second. And that says, if you have 5 $1 bills, then you have $5. So we're going to come back and we're going to look at this example a little more in depth in a second. But first I want to talk about these variations of the conditional statement. So this is the notation used for conditional statement. If P, then Q. Okay? The converse of that would be to flip the two statements and say the conclusion part first and then the hypothesis. And it actually interchanges what the hypothesis and conclusion are, and we'll talk about that more in a minute. The inverse is not P, then not Q. And it uses this notation. That little squiggly symbol, that tilde, represents not. And like I said, we'll talk about what this means with a practical example in just a second. And the contrapositive is kind of like a combination of these two. First, I'm going to flip P and Q. And I'm also going to take the not. So not Q, then not P. Now let's look at what this means. I know I've just thrown a lot of letters at you, but let's look at an example. An example that we have says that if you have 5 $1 bills, then you have $5. So if I'm looking at this, the if part, the P part of this statement is if you have 5 $1 bills. That's the hypothesis, and the conclusion is then you have $5. So let's start with the converse. I can see from my example up here that if I take the original conditional statement and reverse it, I've created the converse. And so what that would be here would be if I take this part and put it first. So if you have $5, then you have 5 $1 bills. I've just changed the order. I've taken my P statement and put it second, and I've taken my Q statement and put it first. Now the inverse is not P, then not Q. So this would be saying if you do not have 5 $1 bills, then you do not have $5. So all I've done is a do not. That's this negation. That's the not part. I'm just taking my original statements and saying the negation of them. If you do not have 5 $1 bills, then you do not have $5. Let's look at the last one. Let's look at the contrapositive with this example. We can see the contrapositive means that my Q and P are interchanged, and it's also the not, the negation of those statements. So this would be saying if you do not have $5, then you do not have 5 $1 bills. So the important thing here is to be able to identify what the hypothesis and conclusion are of a statement, or in other words, what's the P part of the statement and what's the Q part of the statement. From there, if you memorize converse, inverse, and contrapositive, it's just a matter of flipping those statements around and saying not in front of them a few times. It's really a very simple concept. Now, the last thing I want to address is that sometimes, although my original conditional statement might be a true statement, Sometimes whenever I alter it like this, it becomes a false statement. So let's look, for example, down here. The conditional statement is true. If you have 5 $1 bills, then you have $5. That is true. It checks out. But if I look at the converse, if you have $5, then you have 5 $1 bills, is that necessarily true? No, because I can provide a counterexample that proves this false. If I just had a $5 bill, then this statement is not true. In that case, I could have $5, but not have 5 $1 bills. Let's look at the inverse. If you do not have 5 $1 bills, then you do not have $5. Once again, this statement is false because if I do not have 5 $1 bills, I could still have $5 because I just have that one $5 bill, kind of like the converse here. And the contrapositive says that if you do not have $5, then you do not have 5 $1 bills. That is also a true statement. Okay, because if I have the 5 $1 bills, then I have $5. And I know that gets wordy, but the purpose of me saying this is just saying that once I find these variations of our conditional statement, I can prove them true or I can prove them false just by providing a counterexample. A single counterexample in this case would be the owning of a single $5 bill proves both of these statements wrong.